Okay. Yesterday we talked about one sample t-intervals. Today we're talking about one sample t-tests. Shocking. Okay, so before we even get there, I just want to talk through the steps of a hypothesis test in general, because the steps are still the same. If you're going to do a hypothesis test, what's one of the first things you should do? Check conditions or write the hypotheses. Those are kind of interchangeable, right? Well, let's go check the conditions first. Doesn't really matter, though. All right, so conditions. Right, we have the independence assumption, and that goes with randomness and 10%. And then we have sample size, which in this case is nearly normal. Or if you don't have a picture or any raw data, then you'll have to look at the sample size, and it should be greater than 40 or 50 to be large enough. Is that greater than 40? So you're gonna write those all out. Yes? So after we check our conditions, we need to have hypotheses. We're going to have H0 and HA. You always use parameters in your hypotheses, not statistics. Okay, so we talked about this a little bit yesterday, statistics versus parameters, to make sure we got them straight. So you always use parameters like population parameters in your hypotheses, not sample statistics. In this case, we're talking about means, right? So we don't use P. We use mu. If we use P, we're talking about proportions. We're not talking about proportions. We're talking about means. So in this case, we're going to have mu equals, and then mu is greater than, less than, not equal to. See? Still generally the same. After you have hypotheses and conditions, whatever order you put those in, what are you supposed to do before you do that? Yeah, you got to give me a statement that includes type of model, which in this case is not a normal model, a T model with blank number degrees of freedom. And you should also do what in your statement? Right, name the test or the interval, right? In this case, we're naming the test. So name the test. If we were doing proportions with one proportion, we have a one proportion Z test. So this would be a one sample T test. So far, so good? So then after you write your statement, then what do you have? What do you do? Well, you said it. Mechanics, which is just the mathematics, right? So if you're doing a test, what's the first thing you have to find? Standard error, right? Why do we have a standard error here and not standard deviation, and what's the difference? The standard error is an estimate of the standard deviation, right? Now, we're using a standard error because we have S over the square root of n. S is an estimate of the standard deviation of the population. It's the standard deviation of our sample, right? If we had sigma, the standard deviation of the population, then we could have the standard deviation, and we won't have to use a T model anyways. We could use a Z model. All right, after you find the standard error, like in a one proportion Z test, after you found the standard deviation, what did you do? In a one proportion Z test, what did you do after the standard deviation? We found the Z score, right? Well, we're not using Z. So we find T. How did we find Z? Just in proportions, just as argument. How do we find? No, like the z-score. Not always 0. It was always the statistic, which was different depending. It was either p-hat or a difference. Right, it was either 1 or 2, depending. Minus the parameter. So for the difference, the parameter was 0, but for a 1 proportion z-test, it was whatever that was in your null hypothesis, right? It's only 0 with 2 because 0 was in our null hypothesis. That's what we're saying the difference is. And then we divided by the standard deviation, right? Yeah? Okay. So we're doing a one sample t-test. We're talking about means. So what symbol represents the statistic for a mean? And what represents a parameter for the mean? Mu is the parameter. That's for the entire population. So what is the statistic? X bar divided by the standard error that we came up with before. Again, that stuff is on the yellow sheet. It's in words. It just says standardized test statistic. And it says statistic minus parameter divided by the standard deviation of the statistic. So that's your job. If it's z, well, then your statistic and parameter should be proportion related. If it's c, your statistic and parameter should be mean related. Okay? Still the same process, though. After you found, like in the proportions, after you found z, so if you had z equals 2.7, for example, then what did you do with that z? What was the next step? Found a p-value, which was a probability, and we did like the probability that z was greater than 2.7 or something, right? And how did we find that probability? Normal CDF in your calculator, right? Okay. So same general concept. We have the probability that t is whatever, greater than or less than whatever. And so in your calculator, in the same menu where you find normal CDF, you find t-CDF, and it works the same way. Upper bound, lower bound, and in this case, it's going to ask you for the degrees of freedom, which is still n minus 1 for this test, just like it was for the interval last night. Okay, but again, the processes are generally the same. Would you agree? All right, so then after you've done all the mechanics and you have your p-value, what do? What's the last step here? You have a conclusion. Now, some of you guys, and I'm going to be doing this throughout today, have commentary about your tests. We'll look at them later. But I'm not giving you the answers because you can do corrections. So, no, because it's 20-point test. So, some of you guys are missing things from your conclusion. Here are all the things you need to have in your conclusion for it to be good. You need to give the p-value. I know you just found it. I get it. But say the p-value is 0.03 or the p-value is 0.21. All right? That's part of your conclusion. Say if it's high or low based on alpha. It's high or low because why? Why is it high? It's high compared to what? If they don't give you an alpha, then say alpha equals 0.05. It has to be higher than something or lower than something to be high or low. So give that basis of comparison. Then you should fail to reject or reject the null hypothesis. And then you should give context. So on your exam, on the free response, there are some of you that didn't get full credit because you said things like, the p-value is high, so we failed to reject the null hypothesis. That's all you said. That's not in context. I don't know it's higher than what. You didn't even tell me the p-value. Right? Give me something. Or you just said, you didn't say the p-value was high or low. You just said, I'm going to fail to reject the null hypothesis. Well, why are you going to fail to reject the null hypothesis? What does that mean? You got to say something. You got to give me something. So these are all the pieces you should have in your conclusion. The process is generally the same, right? So I don't have a lot of examples to do today because it's pretty much the same thing we've been doing. It's just the t distribution instead of a normal distribution. All right. So can I change the screen? I didn't class. Okay. So here's all the stuff I just said from the book. The assumptions and conditions for the one sample t-test for the mean are the same as the one sample t-interval. We test the hypothesis, h naught mu equals mu naught, whatever it tells us in the problem. We have our t statistic, x bar, y bar, whichever you use, minus the parameter from the null hypothesis divided by the standard error. The standard error is s divided by the square root of n. When the conditions are met and the null hypothesis is true, the statistic follows a student t-model with n minus 1 degrees of freedom. We must use that model to obtain a p-value. It's all the stuff I just said, just from the book. I think me writing it all out is better. Okay? All right. The next question is not a hypothesis test yet. It's just talking about a p-value. Okay? So let me read the question. A researcher tests whether the mean cholesterol level among those who eat frozen pizza exceeds the value considered to indicate a health risk. She gets a p-value of 0.07. Explain in this context what the 7% represents. You all do not know what that means. I've tried to tell you, tried to give you the sentence, but you are latching onto everything else but that. So on the free response question, the last one, I'm pretty sure maybe 2 people out of all of my students got a perfect score because of part D. The rest of it could have been beautiful. And then you messed up part D, so you can't get a 4. And guess what? If you get 3.5 points on a free response question, they aren't going to round that up for you. They're going to give you a 3. 3s aren't bad for the free response, but why not get the 4? All right? Part D on that question said, in part C, you're supposed to check the conditions and they weren't met. All right? So then in part D, it says, using some advanced statistical tests, meaning something we didn't learn in AP Stats. They did it. It works, okay? And it gives you a p-value. And it said, state the correct conclusion based on the p-value, and give what the p-value means in this context. I got a lot of conclusions and a lot of garbage that you guys made up that you thought sounded good for the rest of it. You're like, something about the null hypothesis is true and something percent of something. I don't know. Like, or you didn't write anything at all because you're like, I'm not even going to try to even get to that. I don't know. Okay? So again, a 3 is not bad, but we've been over this, so we're going to do it over again. This sentence I have on the board, you need to write it down. Anything I have in black box is something that will be replaced. This is a template for a sentence. So if you see a black box, that means it's going to be replaced with something from the question. But the stuff in purple should stay the same. Now, you have seen this sentence before, and I have said these sentences before, but it's not sticking. Sentences like it, but now I'm giving you a template that you can use every time. Even for z-test, it still works. So anything in a box we're gonna change out depending on our context of our question. So it's saying statistics, that depends on if we're talking about means or proportions, right? This is gonna come up on your homework. It's gonna come up in this question and the next question. We have to get better at this. Do you know why? It's always on a free response question. They'll say, give the conclusion, but then they'll say, oh yeah, and tell me what it means in context. It was even on your practice test stuff. And I told you in chapter 21 that I was going to come up on the test. See, another reason no one listens to me. I don't know what it is. It's all right, though. We're going to get better at it now. In the question, we're talking about whether the mean cholesterol level among those who eat frozen pizza exceeds the value considered to indicate a health risk. It would be really nice if they gave us that number, but they didn't. And I don't know anything about cholesterol. I'm really sorry. So I don't even know what a good cholesterol level would be. So I'm going to make one up, okay? Because really, our null hypothesis for this question would be that the mean population cholesterol level was equal to whatever that health risk number is, right? And then they're searching to see if it exceeds that value. So our alternative would be that it's greater than that number. We don't know that number. So I'm going to make up a number so the sentence might make a little more sense, but it doesn't, and then I'm sorry. Okay? I'm just going to use 100. I don't know if that's good or bad. That could be way low or way high, or I don't know. It could be nonsensical. I don't know. I'm telling you right now, I know nothing about cholesterol numbers. So, assuming that the null hypothesis is true, that means assuming that the mean cholesterol level is 100. I don't know the units for cholesterol. I am really sorry. I think it's like in some crazy something. Like I want to say it's like in milligrams per something. They're gonna no. So you have, when they ask you, you have it. Probably have done the hypothesis already. So assuming that the mean cholesterol level is 100, that's what I would replace the box with. Okay. The probability that our sample would produce a mean cholesterol level, so that's what our statistic is, that's our mean, at least as extreme as the one we observed, is about 7%. This is the whole reason we made up that, this is where that whole fail to reject and reject came from, is from this sentence. If it happens 7% of the time that we could get these results, that's not very unlikely it could happen. So that's why I'm probably going to fail to reject the null hypothesis. It's not shocking or surprising. If my p-value is 0.01%, well, that doesn't happen very often. That is shocking. So that's why I'm going to reject the null hypothesis. That is what the crux of this is. They want you to know why you're rejecting and fail to rejecting. All right? That's what the AP exam knows that you're going to memorize that you reject when it's low and you're going to fail to reject when it's high. They know you're going to memorize that because you're going to do it so often. They want to know then if you know why. And that's why they're going to ask you to explain the p-value in context. All right? So if it ever says, explain the p-value in this context, this is what you should have. Okay? Yeah? Maybe? We're going to use this again on the next question. All right. You ready to do a hypothesis test? Yes? Excellent. I'm just doing one and I'll be done. In 1960, census results indicated that the age at which American men first married had a mean of 23.3 years. It is widely suspected that young people today are waiting longer to get married. We want to find out if the mean age of first marriage has increased during the past 40 years. So in part A, write appropriate hypotheses. We're talking about mean age, so we know it's not a proportion. And we want to know if it's increased. So what number am I using in my hypothesis? 23.3. Right? Everyone good with writing hypotheses? On part B, we plan to test our hypothesis by selecting a random sample of 40 men who married for the first time last year. Do you think the necessary assumptions for inference are satisfied? Explain. I am not going to write them all down because I don't want to waste that time. We have done this a million times, though, so let's talk them through. Is there a reason to believe this is a random sample? Yes, because it says they're selecting a random sample in the question. Is 40 less than 10% of all men who got married for the first time last year? Yes, definitely. So then we get the sample size. We do not have any raw data. I do not have a picture. So I can't say if it's nearly normal, unimodal and symmetric, right? I really can't say that. So the best thing I can do is fall back on sample size. My sample size is 40. So should 40 be large enough? Should be. So you would just say 40 men should be a large enough sample size to complete our inference test, our one sample t-test. Everyone good with the conditions? Remind me in a second before I give the assignment, I need to go over some things in your calculator. Yes. So part C is really asking for that. So describe the approximate sampling distribution model for the mean age in such samples. And so that's where you kind of write that sentence. Because the conditions are met, I can use a t distribution with, what's the degrees of freedom? 39, n minus 1. Well, 39 degrees of freedom. And I can perform a one sample t-test. So part C is really just asking for that sentence. Okay? Yeah? All right, here's where we get good stuff. Go on part D and E. The men in our sample, so that's X bar, married at an average age of 24.2 years. That's X bar, 24.2 years. Mean of our sample. With a standard deviation of 5.3 years. That's our S. Be very careful. That's the standard deviation of our sample. That is not the standard error we're going to use in the test in 5 seconds. What's the p-value for this result? So they're asking you to do a hypothesis test. We already have all the other steps written out because it broke it all down for you. That was nice of them. Right. The standard error is the standard deviation of the sample divided by the square root of the sample size. So we have to do 5.3 divided by the square root of 40. Make sure you don't use 5.3. You'll be wrong. This goes back to chapter 18. You guys didn't like it then either. They gave you standard deviation, and you would forget that you had to put it back into a sampling distribution model to the test. So you have to use that formula. No, so I'm saying don't use 5.3 as the standard error. You have to use it in this formula. I got 0.838 in prior calculation. Okay? So what comes after the standard error? What do you need to do in our hypothesis test? Find t. So t again is x bar minus whatever your parameter is in your hypothesis divided by the standard error. So that means we have 24.2 minus 23.3 divided by 0.838. Everyone know where those numbers came from and why they're in that order? Maybe? I got 1.074. And again, this is a T with degrees of freedom 39. So if you want to be specific about it, you would write it that way. Okay. So now I got to find my p-value. So we're finding the probability that T is, go back to your hypothesis, it says greater than. So T is greater than 1.074. So you have to use a different distribution in your calculator. You have to go to TCDF. Second bars, go down to TCDF. Yours should be If you did 83, TCDF is on there. I programmed in inverse T, but TCDF is on there. You type in lower and upper like you do with normal CDF. The only thing that's different is you put your degrees of freedom in. 39. So at the end of yours, 100, you'll do a comma 39. So paste, and I get a p-value of 0.145. Right? Any questions on where any of those numbers came from in the mechanics? Again, it's generally the same. We're just using a different model. It's all in the same place in your calculator and everything. Okay. In part E, explain in context what this p-value means. That's exactly that sentence I just gave you. So I'm going to go back to that sentence. And I'm going to erase this other stuff and put in ours because I don't want to write the sentence again. Sorry, I'm being lazy. I'm trying to save you all time. You have to listen to me. So assuming that the null hypothesis is true. Well, our null hypothesis was that the mean age that men first got married was 23.3 years old. The mean male age at first marriage, or however you want to write that, is 23.3. The probability that our sample would produce a mean male age at first marriage, I'm just going to, at least as extreme as the one we observed, is about 14.5%. I'm just putting into context by using the question I have. Right? Questions about that? And then while you're writing, part F, I think it says part F, it just says, what's your conclusion? Right? So our conclusion needs to have some more parts than maybe you guys have been having. So again, this goes back to the question we're working on. Our conclusion could be somewhere along the lines of this. The p-value of 0.145, because you need to give it. It's higher than alpha equals 0.05. They didn't give us one, so I'm using that. But it tells me what it's higher than. So if it's high, what do I do? So I will fail to reject H naught. But then I need to tell what that means in context. So if I fail to reject H naught, what does that mean? There is not evidence that the mean male age at first marriage is greater than 23.3 years old. Make sure you have all that stuff. It's all important. So you guys are going to be little pieces of it, like snippets. Questions? Okay. I'm saying there's not evidence that the mean has changed. You could just say it seems that the mean age has stayed the same at 23.3. But I've started my sentence with there's not evidence that, which means there's not evidence that there's been a change. We're good with that. On at least one of your homework questions, listen very carefully. On at least one, they're going to give you a set of data. Okay? From that set of data, in order to do anything, like a hypothesis test, you need to know the mean and the standard deviation of that sample. So you put it into stat edit, right? I just made up some numbers earlier. And you go to stat calc 1, So you can get the mean and the standard deviation. The mean is x bar, the standard deviation is s. Right, that's where you would find the information. If they just give you a list, they just give you a list, you would use your calculator to find those numbers that they gave us in this last question. Also, if you have a list of data, then it is your job to graph it so you know if it meets the nearly normal condition. So there's two options. Stat plot, you can use a histogram. And decide if that's nearly normal. Again, I made up some numbers. All right. Or, even better, for this condition at least, right under the histogram. This one looks like a scatter plot, but it's not a scatter plot because it's like it's connected. It looks like a line. This one. That's a normal probability plot. If it graphs a straight line, a straight-ish line, then you can assume that your data is normal. If it graphs not a straight line, then it's not. Okay? So it graphs like a scatter plot, and you can see there's a curve at the end, so this would not be normal. We already saw that in histogram. That's not a normal probability plot. It tells you if it's unimodal and symmetric, pretty much. Okay? So you might have to do that. They give you numbers. You finish your calculator. All right. Here's the assignment.